let's make the introduction for the workflow management systems. I already mentioned a couple of times, but this new generation way of pipelines are called as workflow management systems, which provides all components for standard analysis. Actually, they increase transparency and enable long-term sustainability. They aid in achieving a findable, accessible, interoperable, and reusable computational analysis, which makes them fair approach. The examples of them are SnakeMake, Galaxy, Nexo, Pegasus, and Cornwell. These sources are all free to use. Workflow managers uses containers in order to run softwares, which is separated totally from the local environment, which provides them portability and also stability. They provide also scalability because they automatically manage the scheduling, enabling the effective utilization of available resources. Usually, reference files that they are using can be pulled through cloud registries, ensuring you are saving space from your local. They also use strategies for reinterference. They are able to cache intermediate results, avoiding recalculations, which saves time and compute resources. The project repositories are often in GitHub systems, which makes them available for collaborate and also to give feedbacks. And when the execution is finished, they provide options to generate execution reports with detailed information about the run. Which brings us to Provenance, which actually describes the history of a computational environment. It is the execution report. So during the workflow replication or reanalysis, minor changes, usually it is in the workflow environment, software versions, parameter settings, and reference annotations, may or may not change the result itself. But the major challenge is to know and record the exact environment you run your analysis. Data provenance describes this trail of methods, versions, and arguments that we use to generate the set of files. And in short, it is the history of the computation environment you use for this specific analysis. There are two kinds of provenance, prospective and retrospective. Prospective provenance, as the name suggests, is the information before the run, and it refers to the specifications, the recipes that describing the workflow steps and the execution order, typically as an abstract representation of those steps with expected inputs and outputs. Workflow evolution refers to tracing the versions of workflow and data and enabling tracing workflow versions, executions, and the results itself. Retrospective provenance refers to the information after the run, and it will give you information about the execution itself, including each atomic event that consumes inputs and produces outputs. And also, it is very useful in order to get information about the execution environment, like the consumed amount of memory and how many CPUs are used and how many time it took to finish all for this all atomic events. Altogether, Provenance of a workflow will help you a lot in order to record your analysis properly. And also it will lead you to get insights about your execution. By checking the consumed memory and CPU and time, you can actually optimize your workflow. Maybe you can just arrange the resources for scheduling and then make it shorter than you desired. And luckily, Provenance is usually integrated into the workflow management system, which was a real burden for traditional workflows. We already talked about sharing tools inside containers and also sharing workflows through registry services, which makes your workflow partially portable. And as I already mentioned, as GHGA, we are GH4GH, Global Alliance for Genomics and Health Compliance. We are acting their rules. Specifically, GH4GH have 4 API standards in order to make workflow management and analysis totally portable, which means that running the whole system through cloud instead of local. So what we need in order to make this execution through the cloud services, first of all, you need to put your tools and workflows inside the tool registry services, TRS, like Galaxy or NFCore, where you can find your workflows searchable. Second standard is the need to run workflows cloud instead of local through workflow execution services, WES. WES systems usually coupled with task execution service because tasks are the atomic parts for the workflows itself. So in order to maintain this relationship between WES and TES, there is a need for an orchestration system to schedule the runs between them. As a scheduler here, Kubernetes has over the last couple of years as the de facto standard, but there are also Docker Swarm, Nexo Tower, or Galaxy environments to execute the workflows. And final standard is accessing the data through cloud services, because in order to run bioinformatic analysis, we need reference and annotation files. And those are stored in data object services or data registry services, DRS. So this accessing the data through cloud services is through registries, handling reference genomes, indexes, annotations, and other genome assets usually require a huge amount of resource in your local computer, because these genomes are in different formats, and usually there are multiple versions. Here, luckily, data managers, cloud services provides ready-to-use reference sequences and annotations. For example, iGenomes from Illumina, RefGeni, and Galaxy tool, they already provide these bundles for the references. Generally, what they do is to download files themselves from databases like Ensemble, NCBI, or UCSC, and they make them available as a single genomic build for an organism. And by this way, you can have this structure as optimized and standardized. And sharing genomic builds in the cloud enables users to be able to access into the same resources with the community itself, and you will be aligned with them. Also, there are services which provides both storage and database, and also you can use their execution services as compute environment. Those are AWS S3, Google Bucket, and Azure Bucket. As a final component, most important from all, I would like to talk about accuracy of the analysis. Improperly developed, validated, and monitored pipelines may generate inaccurate results. In order to prevent misinterpretation of the data, usually quality control tools in order to check raw data is integrated and embedded inside the workflow itself. After you check the data quality, the second step is post-processes, where you can clean and normalize your data and check for the statistics. The third step is to optimize the workflow parameters. Softwares usually came with the best practice parameter settings, but user usually needs to change them according to the specific analysis. And the first step is the validation of the results. So after you decide on parameter settings to use, it needs to be tested. How you are going to, so after you test it, you need to compare these results with the other softwares. And this is actually performed by benchmarking. Benchmarking is a general term in order, it's used to test a software using a well-known data, which is called as benchmark test data. Those are usually golden standard, and usually community also uses the same data for their test purposes, where you can find readily available results and compare them for the validation. What we do is actually repeat the third and fourth step as much as possible in order to find the optimal and accurate results. Finally, keeping the track of the run and saving the history is crucial for a scientific practice. And it is also a standard for workflow managers. Last but not the least, when it comes how to work productive, visual editors are very effective. And using one of them at least will ease your life significantly. These code editors usually come with a bunch of extensions, additions that you can add into your environment. When you do that, it actually became more than just a code editor. It will be a full stack of workstations. It will ease your life because you can run and debug your code there, and actually you will be able to visualize your results just simultaneously. To work efficiently, a good documentation is also important, and the documentation should be descriptive as possible, being also understandable and also accurate. Markdown with using markup languages enables adding the formatting elements into the usual plain text documents. By this way, it will be readily simpler to read. Working within a team is only possible through good task management. Generally, companies are using commercial ones, but there also exist tools like Trello. Those are the services where you can open a common workspace, common environment in order to split the work you have and assign to add others and direct and monitor the task itself. Finally, I want to talk about our favorite language in GHGA, which is Nexo. Nexo is actually growing fast and it has long-term support from Sequoia Labs. It has been developed since 2030 by more or less the same team. NFCore is a community effort in order to collect and created set of analysis pipelines built using Nexo language. Right now, they have 81 different ready analysis pipelines, including RNA-seq, DNA-seq, single-cell analysis, also to image analysis. But the effort itself is not just restricted to pipelines. They also provide sub-workflows and modules as a single processing running tools. Their modular design is very standard and also flexible for multi-purposing. NFCore is actually a tool package where you can find helper tools. You can create template pipelines, template modules, install those modules into your pipelines, and also create unit tests for continuous integration. And as GHGA, we are working closely with NFCore community in order to generate our standard workflows. It is partially because they have very nice documentations for their pipelines, and also their helper tools comes with extensive documentation covering usage, installation, and descriptions. NFCore pipelines uses GitHub releases, and they also tag their softwares with version, the code, and the software itself, which makes the pipeline releases very stable. Their pipeline dependencies are automatically downloaded and handled readily using Docker Singularity also for Conda environments, which makes usable for anywhere. And you won't be needed to install any software into your local environment. Pipelines usually follow best practices in order to ensure maximum portability and reproducibility. And the large community makes these pipelines exceptionally well tested and really easy to run. And they are releasing their codes through GitHub repositories, and they have continuous integration tests there, meaning that anytime a change is made through the pipeline, it triggers a continuous integration test, ensuring nothing is broken, and only the successfully finished test can be merged. So it is really safe. And finally, through NF Tower, these pipelines are tested through ABS, and there you can even browse the ready results through their websites and maybe use their outputs for your own benchmark analysis. And in summary, created code repositories like NFCore or Galaxy enables the use of best practice pipelines with good templates. And in summary, as GHGA, we are working closely with workflow communities in order to develop and maintain our accurate, scalable, portable, and reproducible fair pipelines. We will be using containers in order to package the tools we use and share them through registries like biocontainers, making them portable, enabling to either work in local computers, HPC services, or execution services like Kubernetes will be helpful for the community itself. Our pipelines will be scalable through GH4GA standards execution with WES and test services will be possible at the end. Currently, we are hosting our pipelines, configurations we have, and the tools we have in GHGA GitHub. You can readily check them out, give your feedbacks, open issues, and leave your comments there. And before I conclude my presentation, I want to re-emphasize the importance of using created best practice pipelines, which will ensure robustness and accuracy. And accurate analysis of bioinformatic data, biological data is the top priority for GHGA. And in order to maintain and demonstrate the high standards for public pipelines, benchmarking studies will be needed. And as GHGA, we have an ongoing plan. And in my next webinar, I will go over the importance of accuracy and benchmarking and NGS workflows. And if you want to be seated, don't forget to sign in. And finally, I would like to give my appreciation to our PIs and workflow teams. And thank you all listening.